Hello my dear student, today we will discuss about projectile fired at an angle theta with horizontal direction. So before we will start this concept, first we know about the definition of projectile motion. Then what is the definition of projectile motion? The motion of the body under the influence only force of gravity, and that motion of the body along a curved path. And that is projectile motion. All of the concept we have already discussed in previous class. So you have any doubt, then first you must be watch the previous lecture video, then you will watch this video. So in previous video, first we learned the first case, that is how can a body projected from a certain height with horizontal velocity, and how can that we say that this path of the projectile is set to parabolic path. Then what is the maximum height? Then what is the time taken by the projectile to project it from this point to hit the ground? All of the concept you have already learned in previous class. And this is first case, that how can a body projected from a certain height with horizontal velocity. This is second case, and as for this case, projectile means that body which is projected. That body projected or fired at an angle theta, and that angle theta make with horizontal direction. So as for this question, first we draw a diagram. So this is horizontal direction, and as for this setting, the projectile of the body fired at an angle theta with horizontal direction. Suppose this body projected from a point with initial velocity u. Suppose the body projected from a point with initial velocity u. As for this heading, when the body projected from a point with initial velocity u, it make angle theta with horizontal direction. And you know that under the influence of the gravity, the body moving along this path, which is called as trajectory path, and mathematically this path is parabolic. So this is your diagram. As for the heading, the body fired with initial velocity, suppose there u, maintain angle theta with horizontal direction. So this is your diagram as for the heading. So you know that when the body fired with initial velocity u, and how can this velocity represent? If we want to calculate the velocity, first we draw a tangent at that point, and that tangent give the velocity of that body. So suppose this tangent represent the velocity with which, the initial velocity at which we fire the projectile, and with an angle theta with horizontal direction. And this velocity having two components. One is vertical component, suppose uy, which is equal to u sin theta, and one is horizontal component ux, which is equal to u cos theta. Then how can this velocity with which we fire the projectile is divided into two components, and this is horizontal and this is vertical velocity, and how the horizontal velocity is equal to u cos theta and vertical velocity is equal to u sin theta? You must be learn or remember, or you must be clear, because you have already cleared the scalar and vector chapter. Suppose I roughly prove that how can this horizontal velocity is equal to u cos theta and it is equal to u sin theta. Suppose this is horizontal plane and we projected with initial velocity u at an angle theta, and this initial velocity u having two components. One is horizontal velocity and another is vertical velocity. So this is like that. This ui is transferred this side. Then we can write this is a right triangle, and this right triangle represents cos theta is equal to base upon hypotenuse ux upon hypotenuse is u. So horizontal velocity ux is equal to u cos theta. Similarly, sin theta is equal to perpendicular by hypotenuse uy upon u. So ui is equal to u sin theta. It is not necessary to mention in this solve for concept, but you must be know about how can ux is equal to u cos theta and uy is equal to u sin theta. So the velocity with which we projected the projectile, that is u, and this initial velocity u is divided into two components. Along horizontal direction this is equal to u cos theta, and along vertical direction this is equal to u sin theta. You must be know or remember this. Then look, this is the maximum height of the projection, maximum height of the projection. When we projected the body reached at this maximum point, and this is the maximum height along vertical direction. This is vertical direction and this is horizontal direction. So the velocity with which we projected the projectile is divided into two components. First we will discuss about these two components. So first we expand this diagram first. So first consider an object projected with initial velocity u, max and angle theta with horizontal direction, and this through which, so consider an object projected with initial velocity u. That object projected with initial velocity u at an angle theta with horizontal direction. That's for the heading. And the velocity with which projected this projectile having two components. This velocity u divided into two components. Along horizontal direction, the u is divided u cos theta component, and along vertical direction, this is u sin theta component. And you have already learned that horizontal velocity is always constant throughout the motion because it is not influenced by the gravity. Because we have already discussed in previous class, the gravity is always, acceleration due to gravity is always experienced in downward direction, that is vertical direction. So this vertical velocity is influenced by the action of gravity. But along horizontal direction, this is horizontal velocity. Along horizontal direction there is no action of gravity. So horizontal velocity is not influenced by the gravity. It is always constant throughout the motion. But vertical velocity is influenced by the gravity because vertically gravity is always exerted towards the center of Earth. So the u is divided into two components. First, the component of u along horizontal direction is u cos theta, which is constant throughout the motion. And why this horizontal velocity is constant throughout the motion? Because it is not influenced by the gravity. Because gravity is vertically exerted, but horizontal velocity is horizontally moving. So horizontal velocity is not influenced by the vertical direction of the gravity. So which is constant throughout the motion because it is not influenced by gravity. Next, second component is this velocity u with which you projected the projectile is divided into two components. One is horizontal velocity, which is constant throughout the motion because this velocity is not influenced by the gravity, but this vertical velocity changes throughout the motion because it is influenced by the gravity, because gravity is also exerted vertically toward the center of earth. So this vertical velocity is influenced by the gravity. So the component of u along vertical direction is u sin theta. Vertical direction, the component of u along horizontal direction u cos theta, but this component of u along vertical direction is u sin theta, which is vertically exerted. So gravity is also vertically exerted, so it is influenced by the gravity and its value is always changes due to gravity. So the component of u along vertical direction u sin theta, which is always changes due to gravity. First, its velocity, it is increases. First it is increases. Sorry, first it is decreases. Then at maximum height it is 0. Then finally it is increases tills the projectile hits the ground. तो जब देखा नहीं जीवा बोले मुझे ना कहूँ चाहिए सेला बुझो. So सुना the तला लाइन की प्रॉब्लम हो जीवा. तो देखा the component of u along vertical direction. देखो हमें जेन velocity द्वारा हमें body को projected करूँ, that velocity u in that velocity is divided into two components, because we know that under the influence of gravity the body projected when the body having horizontal velocity as well as vertical velocity, so that the body moving along this path. So this is u sin theta vertical velocity and this is u cos theta horizontal velocity. Gravity is always exerted towards the center of earth in vertical direction, but horizontal velocity is horizontal direction. So horizontal velocity is not influenced by the gravity, because horizontal velocity is horizontal direction and gravity is vertical direction. So horizontal velocity is not influenced by the gravity, because direction is gravity is vertically and horizontal is horizontally. But vertical velocity is influenced by the gravity, because vertical velocity also vertical direction and gravity is also vertical direction toward the earth center of the earth. So vertical velocity is influenced by the gravity, so its value is always changes. First, its value when we projected the vertical velocity is first decreases at highest point. At highest point, the vertical velocity is 0. Then vertical velocity is increases till the projectile hits the ground. All of the concept I briefly explained in previous class. So first you must be watch previous video, then you clear this video, this concept. So this is most important long question which is basically comes in your exam. So this is your explanation as for this diagram. And how can this velocity divided into two components, and how the horizontal velocity is equal to u cos theta, vertical velocity is equal to u sin theta. All of the concept I will explain. I have already explained. And how can the vertical velocity is changes, because it is influenced by the action of gravity, because gravity is also exerted in vertical direction. So vertical velocity is changes with the influence of the gravity. First its value decreases, then finally at highest point its value is 0, because if its value is not 0, then it is comes highest point, but this value is 0, then this projectile moves downward direction. So at highest point vertical velocity is 0, then increases till 6 ground of up. Now we देखमा equation बाहर करना. First equation में देखमा how can we say that this projectile, the path of the projectile is parabolic. So that is trajectory equation of trajectory, because path is said to be trajectory path. The path of the projectile is said to be trajectory path. So let's see first equation of trajectory. Equation of trajectory. As the projectile moves with two velocity, one is vertical velocity, another is horizontal velocity. Two velocity, it changes it changes x and y direction. That means जेहेतु ये projectile टा ऊपर को जाउची जार horizontal velocity, suppose at this point the horizontal velocity of the projectile this is and vertical velocity is this is, and this is the final velocity through which you projected. Because you must be know that at any instant if you want to calculate the velocity, then first you draw a tangent, and that is velocity, and that velocity is divided into two components, one is horizontal, another is vertical. So as the projectile always changes its two coordinate, x coordinate as well as y coordinate, so we calculate how much distance the body or the projectile cover in x coordinate and how much distance the projectile cover with y coordinate. And if we compare these two coordinates, that is x, y is equal to something x square, then this type of equation represents that the path of the projectile is parabolic, because y is quadratic function of x. This type of path is said to be projectile. So first we want to calculate x and y distance, because the body moving, while the body moving, projectile moving, then this body changes its two coordinate. So first we calculate x, how much distance travel along x coordinate, then how much distance travel along y coordinate, and if we compare these two equations, if these two equations forming this type of equation, then we say that the projectile moving along a parabolic path. So first we calculate in x coordinate. So x coordinate along x direction, the projectile cover a distance x is equal to, we know that x is horizontal direction, and horizontal direction is always obtained by the horizontal velocity. So we know that velocity is equal to distance upon time. So distance is equal to velocity into time. But in this case horizontal velocity is u cos theta. Horizontal velocity is u cos theta, because x is horizontal direction, so velocity is used as horizontal velocity u cos theta. So x is equal to u cos theta. And if we relate it with y direction, then we omit the time. Instead of time we can be use x by cos theta. So instead of time we use x by cos theta. Then we can relate it y and x. So then along y direction or vertical direction, the projectile cover a distance along vertical direction. The projectile cover a distance x एवं vertical direction रो distance देखमा हमें. तो first vertical direction रो distance टा मन रखिथिबो vertical velocity रो calculate हेबा. So vertical velocity, initial vertical velocity केते, initial vertical velocity होची u sin theta in vertical direction. ओहो चौक in vertical direction, initial velocity u is equal to u sin theta. Because हम vertical velocity y calculate करूछु तो vertical direction रो ही सब इक्वेशन नमा सब रिप्रेजेंटेशन. In vertical direction, initial velocity u sin theta. Then in vertical direction, acceleration is minus g. I have already said that gravity is always downward direction, so as per sign convention it is always minus g in projectile motion. Suppose time is t. Then equation, the vertical distance y is equal to ut plus half at square. U instead of u we can be represent u sin theta. Then t is t, ut plus half at square plus half a, instead of a we can be write g t square, ut plus half at square. So if we related x with y, then instead of time we can write that t is equal to x by cos theta. Time is always constant along vertical direction as well as horizontal direction. So from horizontal direction we find that time is equal to x by cos theta. So instead of time we can be use x by cos theta, so that we related x as well as y. So instead of time we can be use t is equal to x cos theta. So y is equal to u sin theta, t is equal to x cos theta minus half g t is equal to x cos theta square. That is y is equal to u t is equal to u cos theta. Sorry, t is equal to u cos theta, because u cos theta is equal to distance is equal to u cos theta upon t. T is equal to u cos theta by x. Sorry, velocity is equal to distance upon time. So t is equal to x by u cos theta. X by u cos theta. Why x cos theta is used? Because horizontal direction. So velocity is also horizontal velocity. So u cos theta is equal to x by t. So t is equal to x by u cos theta. So instead of t, you can be used x by u cos theta, x by u cos theta. And this equation, can लिख लो s is equal to ut plus half at square. s जगह तुम y कोऑर्डिनेट डिस्टेंस लिख लो, u वर्टिकल डायरेक्शन जे तो देखो मन रखिथियो वर्टिकल डायरेक्शन रो सब इक्वेशन यूज होबा, किंतु हॉरिजॉन्टल डिस्टेंस जते बेले कैलकुलेट करू तो से नहीं हॉरिजॉन्टल वेलोसिटी यूज होबा, बाकी जगह रे सब बेले वर्टिकल डायरेक्शन रो वेलोसिटी यूज होबा. जो y वर्टिकल डायरेक्शन तो u जगह थी लिख लो वर्टिकल डायरेक्शन रो वेलोसिटी u sin थीटा t के t प्लस हाफ ए जगह थी लिख लो माइनस g t स्क्वायर के t स्क्वायर. देन हम x सहित y के रिलेटेड करबा আছে, सो t जगह थी हम लिख लो x by u cos थीटा, x by u cos थीटा. So u cancel, so this is equal to sin theta by cos theta, tan theta x minus half g x square u square cos square theta. So look that y is equal to something x square. So this is parabolic equation. So this is represent that the path of projectile is parabolic. The path of projectile is parabolic. एबे हमें देखमा टाइम ऑफ फ्लाइट. एबे हमें देखमा टाइम ऑफ फ्लाइट. Clearly बुझलो. So time of flight is the time required by the projectile to move from A point to, suppose this is C point. So this is first equation, that is equation of trajectory, which represent y coordinate and x coordinate. That means which represent path, and path of the projectile is parabolic. In this path, this is the equation of path. So this equation is namely as equation of trajectory, because the path of projectile is said to be trajectory path, and that is parabolic. So then second condition, we calculate the time of flight. So time of flight. So before we calculate time of flight, first we see that what is time of descent and time of ascent. Time of ascent. Time of ascent means the projectile required or taken time to reach from A point to B point. That means the projectile, the time required to the projectile to reach from ground level to maximum height. That is time of ascent. And time of descent means the time taken by the projectile to reach from maximum height to the projection level. Projection level means horizontal plane, or again hits the ground. That is time of descent. So first we will see that time of ascent is equal to, what is time of ascent? The time is equal to projectile to reach the maximum point or height from the ground. तो तुम मन रखी गोटे जिनटा जे टाइम ऑफ असेंट टाइम ऑफ डिसेंट आम सब जिते भी कैलकुलेट करमा सब वर्टिकल डायरेक्शन के नहीं कैलकुलेट करमा. खाली गोटे जिनटा जे हॉरिजॉन्टल डिस्टेंसटा हॉरिजॉन्टल वेलोसिटी के नहीं कैलकुलेट कर दिबा. सो देखो आम इन वर्टिकल डायरेक्शन डायरेक्ट करमा. इन वर्टिकल डायरेक्शन इनिशियल वेलोसिटी इज u sin theta. Final velocity in vertical direction is 0, because the velocity initially vertical velocity is u sin theta, no doubt, but finally the body reach at this point, and finally at maximum height the final velocity is 0. Then distance and acceleration is minus g. So finally we can use v, u and a. So we can use equation that is v is equal to u plus at. Then we find time. So instead of v you can be use 0, u sin theta. Instead of acceleration we can use minus g into time. And finally time is equal to u sin theta by g. So this is time of ascent. Time of ascent means the time required the body projectile moves from ground level to maximum height. That is t is equal to u sin theta by g. So you must be remember this derivation is derived from the equation that is v is equal to u plus at. Time of flight, the time of ascent. Then we can write time of descent. Time of descent, time required to projectile to reach the ground, or projection level from maximum height, from maximum height. तामे देखो टाइम ऑफ असेंड रे तमर काना थिला प्रोजेक्टाइल टा ग्राउंड लेवल टू मैक्सिमम हाइट के जाउथिला, एबे टाइम ऑफ डिसेंट रे प्रोजेक्टाइल टा मैक्सिमम हाइट रू ग्राउंड के जीवा। तो टाइम ऑफ असेंड रे प्रोजेक्टाइल टा जेते टाइम द्वारा तमर ग्राउंड रू मैक्सिमम हाइट के जाउथिला, किंतु टाइम ऑफ डिसेंट रे प्रोजेक्टाइल टा जेते टाइम रिक्वायर करबा से मैक्सिमम हाइट रू ग्राउंड के जीवा पे। सो लगा देखिए टाइम रिक्वायर्ड टू प्रोजेक्टाइल टू रीच द ग्राउंड फ्रॉम मैक्सिमम हाइट। So in this case also we use in vertical direction, in vertical direction initial velocity u is equal to 0 because maximum height to jete bele projectile ta ground ke jiba maximum height ta initial velocity kete thila 0। हां जदि टाइम ऑफ एसेंट देखबा बेले इनिशियल वेलोसिटी टा u sin थीटा थिला वर्टिकल डायरेक्शन रे और फाइनल वेलोसिटी 0 थिला, किंतु टाइम ऑफ डिसेंट का जैसे फाइनल वेलोसिटी इनिशियली जीवा बिकॉज़ से एबे मैक्सिमम हाइट रो बाहरीबा ग्राउंड के, तो मैक्सिमम हाइट ता इनिशियल वेलोसिटी केते जीवा 0। देन फाइनल वेलोसिटी ग्राउंड के गला टाइम में तार वेलोसिटी इंक्रीज हेबो, जेते वेलोसिटी द्वारा तमे प्रोजेक्टेड करिचो वर्टिकली u sin थीटा द्वारा प्रोजेक्टेड करिचो, तो से u sin थीटा द्वारा ही ग्राउंड के आसबा, तो फाइनल वेलोसिटी हेबा u sin थीटा बिकॉज़ से ग्राउंड के उससे ऑपोजिट डायरेक्शन में, सो वी कैन राइट माइनस u sin थीटा। देन एक्सेलरेशन इज t is equal to minus g। then in this case also we use equation v is equal to u plus at, so v is equal to minus u sin theta is equal to u is 0, then minus g t, minus minus cancel, so finally t is equal to u sin theta by g। so just look it that time of descent is equal to time of ascent, time of ascent also equal to time is equal to u sin theta by g, time of descent is also equal to t is equal to u sin theta by g। तार माने प्रोजेक्टाइल का ग्राउंड लेवल टू मैक्सिमम हाइट को जीवा पाई जेते टाइम दरकार करूचे सेते से मैक्सिमम हाइट रो ग्राउंड लेवल के आसपा का जेबी सेते टाइम रे ही जीवा। सो एबे में देखमा टाइम ऑफ फ्लाइट हम नीचे बुझो जे ए रु बी के जीवा का जे ताके धर टाइम दरकार हला t, बी रु सी के जीवा का जे धर ताके टाइम दरकार हला t, बिकॉज़ दुईटा टाइम समान, टाइम ऑफ एसेंट जेते टाइम ऑफ डिसेंट भी से ग्राउंड लेवल रु ऊपर को जीवा टाइम ऑफ हाइट टाइम ऑफ एसेंट को जीवा, तापर हाईएस्ट लेवल रु तल को जीवा पाई जे टाइम दरकार होचे दैट इज टाइम ऑफ डिसेंट। तो दुईटा तक समान, सो टोटल टाइम ऑफ फ्लाइट केते हबा, टोटल टाइम ऑफ फ्लाइट हबा 2t because time of flight means the total time required by the projectile to hit the ground from its projection point ru आउ थोड़े से ग्राउंड की हिट करबा पाई जेते टाइम दरकार होचे दैट इज टाइम ऑफ फ्लाइट। करेंट पड़ेला टिके वेट करो। करेंट पड़ेला टिके वेट करो टिके। सो टाइम ऑफ फ्लाइट और टाइम ऑफ सब समान, सो टाइम ऑफ फ्लाइट ही जेबा केते 2t मींस 2 into 2u sin थीटा बाय g, सरला u sin थीटा बाय g। सो टाइम ऑफ फ्लाइट हम आराम से जानि परमा, टाइम ऑफ फ्लाइट the time required to projectile to hit the ground from its projection point each time of flight। So we know that time of ascent is equal to time of distance. So time of flight t is equal to time of flight t dash is equal to 2 into t, because time of ascent suppose t, time of descent be suppose t. So total time required to the projectile from A to C is 2t, because A to B by t, B to C by bt. So total time required to the projectile is 2t. So time of flight is 2 into time of ascent descent केते थिला u sin theta by g. So time of flight is equal to 2u sin theta by g. क्लियरली बुझलो, एटा के हमें इक्वेशन द्वारा भी रिप्रेजेंट करी कर बाहर करी पारमा. टोटल इन वर्टिकल डायरेक्शन बाकी ना इन वर्टिकल डायरेक्शन टोटल डिस्टेंस कवर बाय द बॉडी, डिस्प्लेसमेंट कवर बाय द बॉडी. से ऊपर के जेते गला तल के सेते गला. सो टोटल डिस्प्लेसमेंट इज 0 इन वर्टिकल डायरेक्शन. इनिशियल वेलोसिटी इज u sin थीटा, बिकॉज़ वर्टिकल वेलोसिटी ही यूज होबा, हॉरिजॉन्टल वेलोसिटी यूज ही नहीं हुए, खाली से हॉरिजॉन्टल डिस्टेंस कैलकुलेट कला बेले ही u cos थीटा यूज होबा. देन so which time is t and a is minus g. Then we also find this value t by using equation of motion, that is s is equal to ut plus half at square. देखो ये वैल्यू आउट थरे बाहरी बात हम बेसिकली प्रैक्टिकली तो जाना पड़ला, जेते टाइम में से ऊपर के जाउचे सेते टाइम में तल के जाउचे. तो टाइम ऑफ असेंट टाइम ऑफ डिसेंट दुटा जाक समान. तो टोटल टाइम धरो a रू b के जीवा t लागुचे, b रू c के जीवा t लागुचे. सो टोटल टाइम a रू c के जीवा केते लागबा 2t. सो 2 into टाइम ऑफ असेंट होगी टाइम ऑफ डिसेंट दुटा वैल्यू सम पुट कर दे. सो डायरेक्ट बाहरला ई फार्मूला तमे इक्वेशन ऑफ मोशन यूज कर भी बाहर करि पाबो. देखो किंतु फार्मूला इंपोर्टेंट. सो s जगह थी लगभग 0, u जगह थी u sin थीटा t प्लस माइनस लिखि देबो ना, माइनस हाफ g t स्क्वायर, माइनस हाफ g t स्क्वायर, बिकॉज़ एक्सेलरेशन इज माइनस g. बट मन रखिथिबो टाइम ऑफ फ्लाइट रो का इक्वेशन यूज हला s इज इक्वल टू ut प्लस i पर t स्क्वायर. किंतु टाइम ऑफ डिसेंट टाइम ऑफ एसेंट रो का इक्वेशन यूज होतिला v इज इक्वल टू u प्लस t. से साथी टिके मने रखबो. तो देखो लास्ट फाइनली तुम 0 t कॉमन जाऊ तो रहबा u sin थीटा माइनस हाफ gt. सो t आगे पले 0 ही जीवा. सो u sin थीटा माइनस हाफ gt इज इक्वल टू 0. तार माने हाफ gt इज इक्वल टू हाफ gt is equal to u sin theta. So t is equal to u sin theta. This 2 is multiplied and this is divided by 2. So 2u sin theta by g. तो तमे डायरेक्ट इक्वेशन भी बाहर करि पारबो. अदरवाइज प्रैक्टिकली भी जाना पड़े टाइम ऑफ एसेंट u sin theta by g, टाइम ऑफ डिसेंट भी u sin theta by g. So total time is 2t, that is 2u sin theta by g. हला एबे हम बाहर करना maximum height of projection. 3 number equation. Maximum height of projection. मने रखिथिबो इनर का जे इक्वेशन टा यूज हबे v स्क्वायर माइनस c स्क्वायर इज इक्वल टू 2s. एतकी मने रखबाय पड़बा. आ तुमके मु बारंबार कहली सब वर्टिकल डायरेक्शन रो इक्वेशन अगन यूज हबा. हॉरिजॉन्टल वेलोसिटी ओनली हॉरिजॉन्टल रेंज कैलकुलेट कला बेल की यूज इसी. सो टाइम ऑफ मैक्सिमम हाइट ऑफ प्रोजेक्शन मींस द मैक्सिमम डिस्टेंस travel by the projectile along vertical direction from the ground. It is the maximum distance. Maximum height means it is the maximum distance traveled by the projectile along vertical direction. That means this is vertical direction, and along vertical direction from this ground the projectile vertically cover this distance hm. This is maximum height. सो आम इक्वेशन की वर्टिकल रू बाहर करमा इन वर्टिकल डायरेक्शन इनिशियल वेलोसिटी इज केते इनिशियल वेलोसिटी u sin थीटा नो डाउट किंतु मैक्सिमम हाइट रखा जाए फाइनल वेलोसिटी केते हो मैक्सिमम हाइट बेले प्रोजेक्टाइल इन लई जिबा तो फाइनल वेलोसिटी 0 हेबा मैक्सिमम हाइट रखा जाए फाइनल वर्टिकल वेलोसिटी 0 हेबा हला हॉरिजॉन्टल वेलोसिटी तो सब जगह रे समान ही रहबा हला एक्सीलरेशन तमे जानिचो माइनस g एंड मैक्सिमम हाइट इन वर्टिकल डायरेक्शन h so s is equal to h so use karo equation of motion by using equation of motion can equation can use haba seta dikhe mone rakbo time of patient descent raka je use haba v is equal to u plus at then time of flight raka je use haba tomar s is equal to ut plus half at square trajectory path raka je equation use haba s is equal to ut plus half at square अब मैक्सिमम हाइट रखा जाए यूज होगा v स्क्वायर माइनस c स्क्वायर इज इक्वल टू 2as से हिसाब से v केते u केते a केते s केते आगे लिखि देबो सो बाय यूजिंग ऑफ इक्वेशन ऑफ मोशन देखो u sin थीटा v फाइनल वेलोसिटी 0 g माइनस g s होचे से मैक्सिमम हाइट हम जेटा कैलकुलेट करम इन वर्टिकल डायरेक्शन में सो हम ए इक्वेशन ऑफ मोशन यूज करम v स्क्वायर माइनस c स्क्वायर इज इक्वल टू 2as तो फाइनल वेलोसिटी मैक्सिमम हाइट रखा जाए केते होगा 0 होगा this is 0 then this is minus u square is u square sin square theta u square sin square theta is equal to minus 2 g h m minus minus cancel so finally h maximum height is equal to u square sin square theta maximum height is equal to u square sin square theta by 2g u square sin square theta by 2g this is maximum height of project u square sin square theta by 2g फार्मूला मन रखिथिबो फार्मूला होचे बहुत इंपोर्टेंट फार्मूला बसे मन रखिथिबो टाइम ऑफ फ्लाइट रो फार्मूला काना थिला टाइम ऑफ फ्लाइट रो फार्मूला 2u sin theta by g ये मैक्सिमम हाइट ऑफ फार्मूला u स्क्वायर sin स्क्वायर थीटा बाय 2g मन रखिबो फार्मूला बहुत इंपोर्टेंट मन रखिबो न्यूमेरिकल आइडा हम क्वेश्चन पचरेसी डायरेक्ट एबा हम देखमा रेंज हॉरिजॉन्टल रेंज ऑफ प्रोजेक्टाइल so this is maximum height the distance covered by the projectile in horizontal direction vertical direction एबा हम horizontal range देखमा means that distance covered by the body in horizontal direction मैक्सिमम हाइट और डिस्टेंस वर्टिकल डायरेक्शन रो थिला एबे हमें रेंज देखमा रेंज मींस हॉरिजॉन्टल डायरेक्शन रो डिस्टेंस के खोजे जेटा ऑलरेडी तुम जानि छो तो रेंज ऑफ प्रोजेक्टाइल हॉरिजॉन्टल रेंज डिस्टेंस कवर्ड बाय प्रोजेक्टाइल along horizontal direction is range it is the distance लिखबो रेंज रखा जाय सो देखो रेंज होचे हॉरिजॉन्टल डायरेक्शन रो डिस्टेंस तो ई में तुम यूज करि पारबो हॉरिजॉन्टल वेलोसिटी बिकॉज़ रेंज हॉरिजॉन्टल डायरेक्शन रो डिस्टेंस तो एना हॉरिजॉन्टल वेलोसिटी यूज हबा नाले बाकी जगह ती देखुतिलो वर्टिकल डायरेक्शन रो ही कांसेप्ट यूज होतिला सो हॉरिजॉन्टल डायरेक्शन में वेलोसिटी एक्सीलरेशन तो टोटली नहीं ना हॉरिजॉन्टल डायरेक्शन में से खाली वर्टिकल डायरेक्शन में ग्रेविटी रो एक्सीलरेशन होछि तो हॉरिजॉन्टल डायरेक्शन में तुम्हारे एक्सीलरेशन नहीं ना और हॉरिजॉन्टल वेलोसिटी सब जगह रे समान रहबा ई पॉइंट सब पॉइंट तुम्हारे हॉरिजॉन्टल वेलोसिटी सब जगह रे समान रहबा तो से रीजन का सिंपल फार्मूला यूज होबा हॉरिजॉन्टल वेलोसिटी रो जेतु का वेलोसिटी सब जगह रे कांस्टेंट रहबा इट इज नॉट अफेक्टेड बाय द ग्रेविटी तो ता खाली सिंपल फार्मूला यूज होबा u इज इक्वल टू डिस्टेंस अपॉन टाइम so in this case this is range from a to c this is range the projectile moving a to c along horizontal direction this is range r so instead of it can be use r so r is equal to u into t so r is equal to u cos theta because horizontal range so we can use horizontal velocity that is u cos theta then t is t so r is equal to u cos theta into t जगह हम यूज करि पामा 2u sin theta by g 2u sin theta by g यूज करि पामा बिकॉज़ टाइम ऑफ लाइट इ नो एति दूर के जीवा जेते टाइम लागु छे हॉरिजॉन्टल डायरेक्शन से टाइम रे ही जाउ छे तो टाइम जाते हम यूज कर पामा 2u sin theta by g एबा हम एटा सजे कर लिखि पारमा बाबू माने 2u sin theta by g हम लिखि पारमा इटा के u into u के u square so u square cos theta sin theta by g a 2u square cos theta sin theta by g लिखि पारमा एबे हम इटा के लिखि पारमा देखो इटा के हम 2 के आगाडे रखि दमा बिकॉज़ 2 cos theta sin theta जगह ते हम लिखि पारमा sin 2 theta हम इने साइड रे लिखि दी पारमा जे 2 cos theta sin theta जगह ती लिखा दी पारबा sin 2 theta so we can write that r is equal to u square 2 cos theta sin theta is sin 2 theta by g this is range is equal to u square sin 2 theta by g মনে রাখিथिबो एबर रेंज हम जब गोटे बॉडी के प्रोजेक्टेड कर्मा से अधिका रेंज केते दूर जीवा का डिस्टेंस अधिका हम जेते प्रोजेक्टेड कर्मा धरो इटा दिस इज रेंज हाउ हम प्रोजेक्टेड कर्मा से हॉरिजॉन्टल डायरेक्शन रे अधिका रेंज केते दूर तो जीवा मैक्सिमम रेंज केते बेला हेबा सेटा हमें देखमा तो ई 2 थीटा का जदी sin 2 थीटा जदी 1 हेबा बेले देन वी से दैट रेंज इज मैक्सिमम दिस इज आल्सो मोस्ट इंपोर्टेंट सो रेंज इज simply derived from horizontal velocity because the range is along horizontal direction that distance is said to be range so it is simply derived from horizontal velocity and for this is simply formula because horizontal velocity is always constant so formula is only simple that is velocity is equal to distance upon time so distance is equal to velocity into time but horizontal velocity into time because this is horizontal direction of range so for maximum range for maximum range sin 2 theta is 1 sin 2 theta is 1 because sin 2 theta 1 है ही maximum range अब तो for maximum range sin 2 theta is 1 that is 2 theta sin 2 theta is 1 that means 2 theta is equal to 90 degree because sin 90 is 1 we know that so theta is equal to 45 degree so मने रखिथिबो जदी आपण गोटे बॉडी के प्रोजेक्टेड कर्मा 45 डिग्री एंगल जदी प्रोजेक्टेड कर्मा बिल का रेंज बहुत डिस्टेंस तमर जाय की प्रोजेक्टेड हवा रेंज जति अछि दैट से बॉडी इन प्रोजेक्टेड हवा बिल का रेंज बहुत बढ़ी जीवो तो केते एंगल प्रोजेक्टेड कले रेंज मैक्सिमम हेबा 45 डिग्री तो हम जानि तो sin 2 थीटा 1 हेले रेंज मैक्सिमम हेबा मैक्सिमम रेंज रा का जे फार्मूला काना हेबा e square plus g this is also a main formula because sin 2 theta will be 1 so for maximum range u square by g formula but maximum range रो के sin 2 theta 1 हेबा तो 2 theta केते बेले sin 91 है तो 2 theta जगह केते अछि 90 तो theta is equal to 45 degree so हम horizontal direction से 45 degree ने जदी प्रोजेक्टेड कर्मा बोला हम मैक्सिमम रेंज टा पाइना खाली और टिके पढमा न्यूमेरिकल माने कर्मा आज थाउ थैंक यू